Hi, welcome to RTG episode 1. Uh, this is a very classy Google style problem named Russian doll envelopes. So the problem goes like you are given 2D arrays of integers envelopes where envelopes I equals to wi, comma hi represents the width and height of an envelope. One envelope can fit into another if and only if both the width and height of one envelope are greater than the other envelope's width and height. Okay. So return the maximum of envelopes you can Russian doll. So if you have ever saw the Russian doll, you will get what I am trying to say or what the problem is trying to say here. So basically, you can see in the test case like 2 comma 3 can you fit into 5 comma 4 because 5 greater than 2 and 3 4 is greater than 3 and then this 5 comma 4 can get fit into 6 comma 7. So it's something like that if we have this AI, BI, okay, or let's say A1, B1, A2, B2, and if you have A3, B3, the it can Russian doll obviously if this condition satisfy that A1, A2, A3, and B1 greater than B2, greater than B3. So this you need to have fun. Okay. So I mean there are many thing intuition which can come to the mind when you see the problem. Somehow everyone started thinking like, can we get some way of sorting such that we can sort it and just iterate and somehow find the largest number of Russian dolls that we can do. So first, I mean, what was my intuition? The first is I was thinking the greedy way. So how I was thinking the greedy way that let's find a pair, let's say AIBI. Let's say I have and so the at the end of the sorting I have the largest height. Okay. So if I have 9 comma 1 and if I have 9 comma 3 and if I have 7 comma 6. Okay. So I was thinking the direction that okay 7 comma 6 is better because I mean if we take the 9 but the width is 1 you can't take the other width, right? So 7 comma 6 is better, something like square. Okay. But the problem is not to find the best. That is the point. Like if I say you, the problem is not to find the best. Problem is not find the best. It's like chaining. So and we are dealing with two dimensional. Okay. So somehow the brain should click here. It is something related to the LIS problem. This longest increasing subsequence. Okay. If you can think in this direction, the interviewer obviously will find a way that this guy has some way of identifying the patterns. Okay, like he can identify the patterns. So now the problem goes like how LIS is variant here. I mean, we are dealing with two dimensions. In LIS, we have only one dimensions, right? So this is the one of the major and trivial uh, thing you have to find. So I think if LIS O square solution, everyone knows, right? That we build a DP array. I mean, you build a DP array and something like here, vector of int DP n comma 1. And yeah, every and you just find for int I equals to 1 I less than n I plus plus, and basically for int j equals to 0 j less than I and j plus plus, and you will see that if that nums of I is greater than nums of j, so we can say that dpi equals to max of whatever dpj because dpj plus 1 comma dpi. Okay, that if I have a number return dp of n minus 1. So what I was saying that अगर मेरे पास numbers हैं a1 a2 a3 a4, okay, these are the numbers variables. So अगर मेरे को a4 पे end करने वाला चाहिए best sequence ending at a4 if I want to find this at a4. So somehow I want to say that if I know the sequence best sequence ending at A3 or A2, and A3 or A2 is uh, less than A4. So I can extend it. And this is a major idea that we have. So yeah. So sorry, DP of n, and I will say it as sorry, DP of n minus 1 only. Let's run it. देखते हैं, क्योंकि लास्ट इंडेक्स में ही चाहिए ना हमें. So this is the own square solution, right? Or somehow I will ask you to, okay, if nums I is greater than the nums j, uh, हाँ, equal to also, then it also right now, because increasing. Okay, is strictly increasing, strictly, sorry. So it means if it is greater than, then only you can say dp of I equals to max of either dpi or dp of j plus 1. And if I say, I will submit it. Output is 5. Okay. What we're doing wrong here? Uh, the okay, we need to find the maximum. We don't need to find this. ये नहीं करना है हमें. हमें मैक्स फाइंड करना है. कहीं पे भी एंड हो सकता है ना. लास्ट वाले पे एंड होने वाला, लेट से, इफ इट इज अ बैड आंसर. सो मैं ये करता हूँ, पॉइंट आई इक्वल्स टू 0 एंड आई प्लस प्लस आंसर इक्वल्स टू माइनस ऑफ आंसर कॉमा dp of I, and this will be your, because we are finding the largest subsequence which can end at anything. हमें ये नहीं है कि लास्ट पे ही एंड होना चाहिए, ठीक है. तो दिस इज द ओन स्क्वायर सॉल्यूशन. नाउ इफ आई से यू फाइंड द ओ एन लॉग एन सॉल्यूशन, तो देन व्हाट वी डू हियर इज, हम क्या करते हैं कि वी ट्राई टू फाइंड ए वे, जैसे वी ट्राई टू फाइंड ए वे दैट, एक हमारा सबसीक्वेंस जनरेट हो रहा होगा, राइट, एक सबसीक्वेंस, हाँ. एंड व्हाट वी ट्राई टू फाइंड ए वे दैट, अगर हमें कहीं भी बड़ा नंबर मिलता है, if some at the place if I'll get a bigger number, then it's fine, I can extend my subsequence. But if I somewhere I found a number which is less than or equals to the number which is at the last step, like, then you will try to replace it with the just increased, just greater than the any number in the subsequence array. So what I'm trying to say is, I will show you with example that if we have one pre 7 7 4 5 2, okay, ये है अगर हमारा, तो this is there 1 3 6 7 increasing, but 4 when you find na, you try to stitch 4 here. Yeah, 1 3 4, that's what I'm trying to say. This is the kind of O and log n idea, uh, what is there. So basically you just build a vector here, just build a vector here, vector int temp, and uh, you just iterate over here, int I equals to 0, and yeah, you just do nothing, you just find the lower bound of the number, lower bound of the current number, comma temp dot end comma x, sorry, num size. Okay, if temp dot end, it means uh, all numbers are smaller than it, then just temp dot push back x num size, and else you will replace the number what was that iterator with num size. Okay, and you just return temp dot size. This was the size. Okay, this thing you just do here. So you can see here, this is the way of finding in O and log n. Okay, so I mean, coming back to the problem, why we are thinking in this way. So let's say I say you that we have two parameters now, width and height. So I say that sort the width in increasing order. Okay, तो एक डायमेंशन से तो सॉर्ट हो गए हैं, वी आर सॉर्टेड विद वन डायमेंशन. ओके, विथ वन डायमेंशन. बट इफ आई आस्क यू, जैसे मेरे पास ये हो गया 1,2, देन 1,2, देन 1,3, देन 2,4. तो आई वॉन्ट टू फाइंड द लॉन्गेस्ट इंक्रीजिंग सबसीक्वेंस. अब मैं फाइंड करूंगा लेट से, तो 1,2, 3, 4 ऑल कैन फाइंड, बट 1,1 तो नहीं होगा क्योंकि विड्थ इज सेम. तो समहाउ ऐसा हो जाए, समहाउ वी नीड टू sort in the sort in the order such that we can avoid duplicates. So we will sort the height in the decreasing order. Okay, that's what we will do. So यहाँ एक लिख देंगे static bool comparator int a comma int b. Okay, एंड यहाँ पे हम सॉर्ट कर देंगे, इनवर्स को ई बोल देते हैं, एंड हियर वी विल सॉर्ट int n equals to e dot size, sort e dot begin comma e dot end. और यहाँ कंपैरेटर का कोड ऐसा होगा कि इफ ओके, सो यहाँ पे जो नंबर ले रहे होंगे दैट इज टू डायमेंशन नंबर, राइट. तभी तो हम बोलेंगे कि अगर इफ जीरो इज a zero, then it's a problem. Return a1, b1, return a1, b1. सॉरी, ये इधर और ये इधर. हम्म. हम्म. ठीक है, समथिंग लाइक दिस वी कैन डू. सो या, और हमें फाइंड करना है दैट इसका LIS क्या होगा, दैट वी नीड टू फाइंड, राइट. सो व्हाट वी विल डू इज, हाँ, ये इफ a0 इज ग्रेटर देन b0, सॉरी, तो a1 इज ग्रेटर देन b1 कर दो, एंड a0 b0. सही है, राइट. और सॉर्ट कर दिया मैंने, एंड व्हाट वी विल डू इज हियर पॉइंट I इक्वल्स टू 0 लेस देन ni प्लस प्लस. अब h इक्वल्स टू ei 1. ओके, और सेम कोड करेंगे, वी फाइंड दिस लोअर बाउंड इन द टेम्प एरे जो हम बिल्ड कर रहे हैं. ओके, एंड h if it equals to temp dot end with the temp dot push back h else star equals to h, and you can just return temp dot size. So this should be it. Let's try to compile here. Static bool comparison. Okay, we can't do like this. So we need to pass it our vector. Mm. Or we can write a lambda also, right? So what we can do here is we can take a vector int vector of n a and vector of n to b. This must define, and we make a vector of m, and submit it. So this the beautiful idea in this problem is how you can think in LIS direction and then just so get sorted with one dimension and take the maximum for one. So yeah, this was the episode 1. We'll meet in the episode 2. Till then, yeah, bye bye.